Thank you everybody for still being here on Friday afternoon, the last session of the conference. I'm sure everybody is very tired already and looking forward to have fun this weekend. And mostly thank you for our speakers who are here on a Friday afternoon in a conference that is not their conference. They're here to share their knowledge and their experience. And today, as part of theme 15, Geology in a Cultural Lens, we are going to look. What's happening? Could you see if Alex Gorman is online? I know the last speaker is online, but we're missing Alex. I want to make sure she's on the. Okay, thanks. Okay, sorry. So we are going to shift, and in the session about geology in a cultural lens, we're going to look up in the sky, and our first speaker will talk about how the Hawaiian people research the sky, look at the sky, observe the sky, and it's an opportunity for us to learn about this. So with that, the speaker will introduce herself and we'll get started. And as the other speakers will come, we'll shift to their virtual. Yes, you need that.
Okay. All right. Aloha, everyone. Good afternoon, good morning to those online, good evening to those online, and wherever it is everybody is on this planet, aloha. My name is Kale Nu'uhiwa, and I come from the island of Maui, although I reside in Hilo on Hawaii Island, which is the Big Island, known as the Big Island. I work with a family foundation by the name of the Edith Kanakaole Foundation, and they are a family whose interests are to elevate and explore ways in which there are intersections between indigenous science, specifically Hawaiian science, and Western science. I'm also a fellow with the Conservation International and in the Oceans program, and I'm doing the same thing actually there too as well. So looking to see where there are cross intersections between Western science, indigenous science, and then ways of knowing too, and other different kinds of pathways. So I'm here today to talk about a project that the Edith Kanakaole Foundation has been working on with in the last 15 years called Papakumakawalu. And I've got my time going, so I'll stick to my time, and I'll take questions, I think, at the end after everyone else. Yeah, okay. All right, so Papakumakawalu is a process in and a methodology, and is also a pedagogy too, in ways of teaching, discovered and developed by Dr. Pulani Kanahele, who is one of the daughters of the Edith Kanakaole Foundation, the original founders. And she's very interested in sort of developing the methodologies that she saw in a lot of chants. So our research looks into rituals, ceremonies, songs and chants, and then eventually we look at stories too. We don't really pay attention too much, well, I shouldn't say that. We look at the narratives afterwards of stories as they apply to what we have found. Oh, I'm gonna go. We have found that in chants and rituals, because it's a ritual, it tends to stay the same over generational changes, as opposed to narratives which change over time because there's a need to sort of articulate things that may have come from the past and doesn't necessarily apply to today, which then has to be innovated, and then elevated into knowledge of that time itself. So we tend to stick to rituals and chants and ceremonies and songs in order to find the data. We call these our databases in which we go into and pull out all the different information that can be found within those databases. So this was discovered by Dr. Puolani Kanakaole Kanahele, and so she points to a particular chant, which is a cosmogonic chant called the Kumulipo. And I don't know if folks have gone to the other presentations. We had 2 other presenters who talked about it. So I'm just going to give you a very brief overview of what they may have said. And then I'm going to move into my specific topic that I've been studying in the last 20 years. Okay, so the Kumalipo is a 2,102-line chant. It was recorded at the time of Kalakaua, who was a monarch here in Hawaii. And he took the Kumulipo with him when he circumnavigated the globe, because it has elements of the Big Bang theory in it. There's elements of creationism in it. There's spirituality in it, there's religion, there's politics, and there's this idea of genealogy, and also another idea of evolution. And sometimes it has to do with Bayara and how those things evolve, but it also has to do with the evolution of maybe a thought process, a political move, the reasons why people left different islands, homelands, and then settled elsewhere. So it's written in a genealogy style, sort of like, DNA, how DNA is. And so that means you can trace back to something from the past, as antiquitous as it might be. And you can also move forward too as well, into the future. And what's important is that things are sort of understood in the present too. And so there's always this familial connection to the environment, to the earth that we live on, to the sky and its cycles, and then all of the Bayara as they reproduce and go through their own genealogies. So it's a Hawaiian methodology of understanding the universe around us. The Kumulipo was composed at a time when we weren't actually called Hawaiians. So it was before Hawaiians became Hawaiian. And it doesn't exactly say who we were, but it does say that we moved several times and it gives us many reasons why we moved. So it's a methodology that helps us understand all of the cycle, seasons, and activities that are naturally happening around us. So what Dr. Puolani did was to take the actual process, give it a name, because it wasn't named Papaku Makavalu before. She decided to call it that, and I'll explain why. So Papaku means foundation, so any kind of foundation that has a platform, any kind of platform, I should say. Makavalu, on the other hand, that particular word has to do with deconstructing and having many, many different parts coming from a source, but then sort of dispersing out of itself and moving beyond where it originally started. So we like to use the image of a fern to describe what Papaku is. And you can look at a fern tree. We have fern trees here in Hawaii, or any kind of fern, and it's in the earth. It has a need to reproduce, but when it starts to grow, it is its own individual, and then it creates a leaf, and then it unfurls a leaf frond, and the frond unfurls, and inside of each of those leaves are tinier leaves too, as well. And if you flip the leaves over, these are usually where the spores are located, which then says that these spores will be dispersed eventually, and then create a whole new world, or a whole new platform on their own. So it is a way in which we can describe the source of something, where something originates, where something blooms out of it. We look at all of the different components that each of those fronds, as you will, may have, and then all the little leaflets within there are all individual Papaku as well. And then after that, they can potentially become their own selves too as well from their spores. And like a genealogy, you can trace it back to the original plant that it had come from. So she discovered this type of pedagogy and methodology of articulating the universe in that chant that I was talking about, the Kumulipo. And she discovered these 3 lines in the chant. And each of the lines, when we study the lines in that 2,102 line chant, each of the lines actually refer to a particular story. And in the lines, you'll have a whole sentence. But when you get sort of towards the middle of it, or a little more than the middle, when you get, all of a sudden you see just these single words. And then afterwards, following after these words, come this idea of knowledge, come this idea of people becoming experts in things around them, and then actually actively engaging with the environment. And so those 3 words are Papahuli Honua, Papahulilani, and Papa Nui Hanau Moku. So Papahuli Honua, if we separate the words out, Papa again means a platform or a foundation. Huli means a cycle or evolution or to revolve. And Honua means the earth. So if you put all 3 of those words together, Papahuli Honua, it actually means the study of the natural processes, evolutions and cycles of the earth itself. So this includes things like water on the earth, the water cycle on the earth. It can be volcanology, where rocks come from, the whole process of lava. We have a lot of chants that talk about that too as well, a lot of Pele chants. The ocean too as well. So any kind of thing that has to do with the earth itself and the natural cycles and phenomena that it produces. This does not include Kanaka or living beings. It's just the natural part of the earth. And then what I'm going to be talking about in a little bit is Papahulilani. Okay, 9 minutes. All right, I'm good with my time. Okay, so Papahulilani, if I separate out those words, Papa again means foundation. Huli is evolution, cycle, season, to revolve and to evolve. And then Lani means the atmosphere or the sky specifically. And we choose not to use the word heaven because it has a connotation of an outside religion. So instead we use the term sky or atmosphere. So this has to do with things that are naturally in the sky, which includes the sun, the moon, and we'll go more into it, but the sun, the moon, the stars, the atmospheres, the strata that are in the atmosphere itself, and then time. We look at also the clouds, weather, wind, rain, and all the things that are affiliated with that too as well. So this is situated in the sky. It is the study of the sky and not of the earth. So things up there. Again, void of man and also, or I shouldn't say man, humans and living bayara. The 3rd word that was in the chant was Papahanau Moku. And Papahanau Moku, again, platform, stage, a basic place or space, a foundation of Hanau. Hanau means to give birth or to reproduce. And Moku, a lot of times it's translated as an island or a mountain, but actually Moku means individual. So if we put the 3 words together, we get this idea about a foundation or a study that understands reproduction and the movement of life and those things that need to reproduce. So anything and everything that reproduces goes into this category, and man, Kanaka, humans, sit in this category too as well. So although we're sort of the Johnny-come-latelys in the whole evolution of everything. So we find things like the corals, seaweed, fish, birds, plants, animals, all those things that roam and fly and breathe the air, well, live on the planet. Are we clear so far? I think so. Yeah, that's pretty cool, huh? Yeah, okay, all right. So I'm here today to talk about Papahulilani in my last 6 minutes. So, what's that? Oh, okay. I just want to make sure I stay on time, because I'm very famous for going off the subject and then carrying on with myself. So I'll make sure this yeah, keep on time. Okay. So I just described what the terms Papahulilani mean: stratum, layer, foundation, to turn, change, cycle, revolve, evolve, Lani, atmosphere, sky, space. So what happens is we put the house of knowledge, which is how it's referred to, in the center. And the process by which we go into the chants and things is to deconstruct it, is to deconstruct the things that we find off of that topic. So you can put any topic in the center, and then you deconstruct out its components, kind of like when that fern was unfurling. And you start to look at all the different parts that describe that particular topic. So for this topic, I'm choosing Papahulilani to show you what the different components are. And the thing is, you can actually deconstruct it in many different ways. This is just one of the ways in which I decided to deconstruct it. So it will be wind, it can be the sun, it can be the moon, it can be clouds. Ao is actually weather too, it can be weather, and then from weather it can expand out to other things, which include clouds. And then it can include rain, precipitation, and those kinds of fog. And so it'll just keep sort of being deconstructed, each component. Leva, or atmospheres. So we have different zones in the sky based on where the sun is located, or what kind of air we see in the strata. Those have names too as well. Those go in that component. We have stars too as well. And for Hawaiians, the word hoku also includes planets and meteors and comets and those kinds of things that are up there and beyond. Wind can have its own category, rain can have its own category, and it can continuously be deconstructed. The idea is that you look at the topic, you pull out all of its components, you study those components, and then you decide whether or not you want to deconstruct each of those components further and study those different things even more, and continue to do that as far as you want. So in some ways, it's like a genealogy where it has an origin, it has a topic, a beginning, and as you deconstruct things, you'll see that there are themes that start to pop up. So Ao, everybody say Ao, who's here? Ao. Yeah, very good, okay, Ao. So that's our general term for weather. So it can be clouds, it can, as I was saying, it can be wind, it can be rain, it can be rainbows, all those things. So it sits on that. Hoku, which are stars. So the important thing about weather, stars, the moon, and the sun is that all of those components helps people, Kanaka, humans, to track time. So you find that one of the main components that sits in Papahulilani is the ability to keep track of time. So Hoku is one of them. La, sun, everybody say La. Very good. You didn't know it was going to be audience participation, did you know? Okay, 3 minutes, Kale. Okay, Mahina, everybody say Mahina. Very good, that means the moon and all of its cycles, the lunation of the moon, where it is in the sky, when it's up there, its names, what can and cannot happen, biodynamism that happens with that too as well, we study that, how it affects the ocean, how it affects the earth. Everybody say Makani. Very good, that means wind. So we study all the winds. We have 456 names for winds. We have 402 names for clouds. And even just a lot more rain too as well. Everybody say leva. So if you look at this, there's actually a site at the bottom there. So humans actually built that site below, and what it does is it tracks the movement of the stars, how the sun moves across, keeps track of time. Yeah, and that's one of our comments that should have popped up. So anyway, this is my little animation, which I'm not going to quit my job or apply to someplace like Disney. But this is actually what happens: is you have a topic or a subject in the middle, And what Makavalu does is it Makavalus, it deconstructs everything out. And then you study all of those components, and then you can deconstruct that even further and further and further. And the idea is to get a holistic understanding of that topic that you're looking at. And then what's important about the analyzing part of it is eventually you reconstruct it back to its original source or the original subject. So when I talk about Papahulilani, it doesn't just mean Papahulilani as a word. It now has all of these other components that are connected to it. And so when I see that word in a chant in our database, all of these different connections that are affiliated with that one word are now brought up to the surface. And then we can glean and understand knowledge on how or why the chant was composed and what the original person who saw the empirical data, what they saw, and how did they keep it in that chant. So this is what Papahulilani would look like if I would continue to deconstruct it, and it would move on and on and on. And then eventually it would come back into itself. And so, mahalo, that's it. That's all I have for today. And thank you.
So moving on from looking at how Hawaiians looked at the sky, we're actually, Alisa will follow up with issues related to planetary protection and planetary safety. And you just move here with you introduce yourself.
But that is Alice.
Oh yeah, the next one, please. Not this one, the next talk, sorry. Till it gets on there, you can introduce
that's
yourself.
helpful.
That's
Wonderful.
There.
Perfect. Thank you, Adina. And I know how things work, and it's last session, last day. So please join me in thanking Adina for this wonderful theme that she led this entire week. Thank you so much, Adina. You don't want to keep that for the very end. So hello, everybody. My name is Alisa Adaji. I teach space law, policy, and ethics. I created a transdisciplinary curriculum, and we're going to do a lot of deconstruction. So I'm very thankful for this lovely segue to what we're going to talk about. I am not a geochemist. I did a master in oceanography before doing a turn to space law and policy. And I worked as a planetary protection officer and then now working on planetary defense. So I'm going to use those two case studies, planetary protection and planetary defense, to tell you a little bit about the sky, to tell you a little bit about space, but also to bring up some ethical questions. And you'll see that if you look at the law, you will have some ethical questions. If you look at policy, you will have some ethical questions and connected to our culture. So I'm going to start. Here we go. Trying to stay on time. I will not, but I will do my best. So if you've been in several of those sessions, we talk a lot about definitions, and I'm going to start with definitions also because just in any language, defense and protection, also specifically in my language, in French, they're oftentimes used as synonyms when they're absolutely completely different fields of research. So I'm going to start with some definitions to make sure we're on the same page. Then I'll tell you a little bit about the history of planetary defense management so that we can look at the policies and the laws that encompass that field, and then get into the juicy legal aspects. And I know when I say legal aspects and juicy in the same sentence, you disagree with me, but I promise you it's going to be interesting. And I'm always finishing on a to know more section because I want you to be able to find the resources. If you've never taken a space law class and this slightly interests you, there's actually a lot online for you to dig your teeth into. So those definitions. Planetary defense, completely different from planetary protection. Planetary defense just imagine an asteroid may impact the Earth and you need to push it away. Planetary protection is what you need to do to decontaminate your spacecraft when you send it out and to do what is necessary to bring samples back. We know that in parallel sessions we talked about OSIRIS-REx and sample returns. Well, that's planetary protection. These two have in common the notion of asteroids, the fact that we're going to asteroids. Sometimes with planetary defense, we're thinking of asteroids that can impact us. And sometimes when you look at Hayabusa and OSIRIS-REx, you're going to asteroids to get samples. But that's the only interaction. When we talk about law and policy, people working on planetary defense usually are not the same people as the one working on planetary protection. And you can see two reports in those corners, and I zoomed in on those here. So on the left side, you have both of them are available online for free. One is the legal aspects of planetary defense working group report that was that ended about 2 years ago. We're doing a second series in second volume next year, so stay tuned. But if you're interested in the legal aspects of planetary defense, you can find all it detailed here in about 100 pages. Same thing on the right side. Your right side, yes. International Planetary Protection Handbook, simply because when you decontaminate your spacecraft, you have different ways to do so, different methods and chains of management, and it varies depending on the countries. So we went to China, Japan, the US, Europe, and tried to figure out what were the points in common and what were the lessons learned for managers. And I cannot talk to you about planetary protection and planetary defense without telling you a little bit about space law. And it was really hard for me not to transform this whole talk on an intro to space law course, so I'm going to contain myself. But the main thing you need to know about space law is that there's this Outer Space Treaty from 1967 that was signed by 111 countries, which means that it's really broadly accepted as the core of international space law. In this treaty, there are several articles. I'm just going to select 3. One, just for you to know what is in Article 1 of the main Space Law Treaty, it says that the exploration and use of outer space has to be for the benefit and in the interest of all countries. And then there shall be freedom of scientific investigation in outer space, and states shall facilitate and encourage international cooperation in such investigation. That explains, that article put in place explains a lot of the international space research efforts. In Article 2, there is this big question of national appropriation. And nowadays you hear about it a lot, especially if you heard of the question of space mining and space resource utilization. And usually people come back to this Article 2 and how to interpret this Article 2. So Article 2 says, outer space, including the moon and other celestial bodies, is not subject to national appropriation. Certain countries will interpret this article and say that thus extracting resources from an asteroid and owning those resources could be seen as appropriation. Other countries will take the examples of countries that fish in waters and they do not own the Pacific, but the fish that they are taking out is theirs. That is one of the core discussion nowadays when you look at space resource utilization, and I am going to jump now to talk to you about Article 9, because this is the one that brings some ethical questions regarding planetary protection. So again, planetary protection, what do you do to decontaminate your spacecraft when you send it out and when you bring samples back in? In Article 9, it says that it's important to avoid their harmful contamination. We're talking about celestial bodies. I'm going to start the sentence. State parties to the treaty shall pursue studies of outer space, including the moon and other celestial bodies, and conduct exploration of them so as to avoid their harmful contamination and also adverse changes in the environment of the Earth resulting from the introduction of extraterrestrial matter. You're noticing that it doesn't say also adverse changes in the environment of celestial bodies. We're saying changes on the Earth. And that is one of the questions that raise Article 9. Out of Article 9, the UN turned to COSPAR, which had another name at the time, and COSPAR is the International Committee on Space Research, a committee of scientists, and they are in charge of interpreting and applying Article 9. But COSPAR is a group of scientists, so the way they interpreted this article and applied it was to say it's important for the science not to create false positives. So when we go on another planet, we want to decontaminate our spacecraft, because if we leave some human contaminant, we will try to find life on another planet and we're going to test it. And on Mars or Moon or wherever, we're going to find Earth matter, and thus we're going to create a false positive when we're trying to look for life. And that's absolutely understandable. But then you end up in this situation where the international committee in charge of putting this article into application is focusing on the science. And it makes sense because that's what they're supposed to do. But this entire other area that says that there shouldn't be harmful contamination at large on other planets is left unexplored. And so you could imagine at some point groups like, the WWF of space saying Mars has its rights and is not supposed to be contaminated by Earth matter. Not because it would create false positives, but because Mars and other celestial bodies should not be owned by Earth and should not be used the way Earth humans want it to be. But that's not how the law is put in place. We have the Article 9, it's open to interpretation. Article 9 of the Outer Space Treaty is dealt with by COSPAR. COSPAR focus on the sciences, and everything that has to do with the ethics of going to other planets and potentially contaminating them for other than scientific purposes is left up for debate. I could say so much more on planetary protection, but again, time. Feel free to find me if you want to talk more about this, but now I'm going to jump to planetary defense. The definition here comes from SEMPAGE. SEMPAGE is an acronym for Space Mission Planning Advisory Group. It's a group, so if you've ever been to UNUSA, the United Nations Office of Outer Space Affairs in Vienna, it has 3 committees, a technical subcommittee, a legal subcommittee, and a general committee that meets every year at different times. And under the technical subcommittee of UNUSA, you have one of the subcommittees has SEMPAGE. And this Space Mission Planning Advisory Group works in parallel to another one called I1. And I'm not going to kill you with too many acronyms. You just need to remember that I1 is a group of scientists representing agencies and sites around the world that detects asteroids and comets, and SEMPAGE works on planning a potential mission to push away a threatening asteroid. And the joke here is that everybody needs to be on the same page when it comes to pushing away an asteroid. So SEMPAGE defines planetary defense as all the activities and action to predict and mitigate a potential impact by an asteroid or comet on Earth. Mitigations are measures designed to prevent, predict, prepare for, respond, monitor, and mitigate the impact of all these disasters. A near-Earth object, we're talking about an asteroid or a periodic comet that has an orbit that brings it within 1.3 astronomical unit of the Sun. For simplification purposes, I will mostly talk about asteroids. Even in our exercises, we mostly talk about asteroids. And the final point here is the definition of a natural threat. I'm not going to go through all of it, but the point is our definition of a natural threat is set by the United Nations. And if you look at this, at the time they were defining natural threat, there were no talk of planetary defense. There were no talk of a potential threat of an asteroid impact. So a celestial impact, a celestial threat is not part of the United Nations definition of natural threat. So if we want to be able to apply UN policies, we first need to change that definition to have it included. So you can see biological, geological, seismic, hydrologic, or meteorological conditions. And an asteroid coming towards us is not really considered a meteorological condition. So we're working on that. The notions, asteroid, comets, as I said, I'm going to focus on asteroids. NEOs is for near-Earth objects, more than 20,000, and PHO is for potentially hazardous objects. The potentially hazardous objects, or 2,000 are tracked, 800 are focused on because they could become hazardous. Very important distinction between a hazard and a threat, and that's very important when you go to different populations, the way you use your vocabulary, how you're going to incite potential panic, or use terms that could reinforce the sense of security. A hazard, again, there are many definitions, but to make it simple, a hazard is a non-confirmed threat. So you're observing something that could become a threat. It is hazardous, and we have 2,000 potentially hazardous objects. And when the hazard is confirmed, we're now talking of a threat. So in 2029, when we'll talk about Apophis coming near the Earth, I'm counting on all of you not to say that this asteroid is a threat to the Earth, because it isn't. Same thing for disaster and catastrophe. We use the word catastrophe very easily, very often in our vocabulary, but in general, when we think of that field, disaster, we are thinking of local, national disasters, and catastrophes, we're talking about global effects if an asteroid were to impact us. And finally, scotomization is a term from psychology, and it's something that people in the field of planetary defense need to take into account when dealing with populations that may have to be displaced. This word comes from psychology and has been applied by anthropologists and ethnographers who went on the field in field sites of volcanic eruptions and tsunamis. When you tell the population that they need to leave, there's so many reasons why somebody could decide not to leave their home, for cultural reasons, because they do not believe you, fake news and all of that. But scotomization is an effect where the person cannot absorb the information because they have never heard of something such as this in their lives. So the information is not absorbed by the brain. So you will tell somebody, an asteroid is coming and it's going to destroy your entire country. That's not something that humans have ever had to face. The only other example that we have dates from the dinosaurs. So we kind of know of the concept, but it is highly probable that some people in the population will not be able to absorb the information when we communicate this for them to be able to move, which needs to be taken into account when we think about emergency responses and how to move these populations. Little note about when you show, stats and data to the general public. When we showed this to, students in my classroom or people from the general public when we do public exercises. You're a scientist, you know how to read this. It says that there is an increase of near subject detection. However, if you're not careful with the title, you can have the feeling that there are just so many asteroids and comets, and it multiplied between 2000 and now there is a real threat. So it's the kind of translation of graphs that we try to do as well, not to promote wrong information. In terms of sizes, in general, when we do our simulation about planetary defense, we think that an object that would be smaller than 140 meters would have national effects. An object larger than 300 meters would have large regional effects. And an object larger than 1 kilometer would have global effects. And then we would probably talk about a catastrophe. And in terms of the management, I'm, again, not going to go through all of it. In blue, general piece of information, facts. In 1994, there was the comet Shoemaker-Levy 9 that impacted Jupiter. You have the missions of Hayabusa in 2003, the research on Apophis in 2004, the meteor of Chelyabinsk in 2013. But what you see in orange are actually the policies that came from those events. So you have the science, and then policymakers decide to do something about it. So after 1994, there was a team that was created to do research based on the observation from the impact of the comet on Jupiter. And in Unispace 3, which is the name of a big assembly at the UN level, they decided to create in 2001 AT14, meaning Action Team 14. Had a really cool name, which was then put in charge of deciding how do you make decisions? How do you design a system to deal with planetary defense? And the way to do so was to create something at the international level. And you will see, and it depends on the field, but for planetary protection and for planetary defense, it first starts at the UN. It starts with science, then it starts at the UN, and they launch an international effort, and then it transforms into national efforts and national policies, then put into law. So in this case, in 2014, I1 and SemPage, the two group I told you about, were created, and they decided also to incorporate in the IAA Planetary Defense Conference a scenario so that scientists would be able to, in some way, role play what would happen if an asteroid were to strike. What would be the tools that would be used? How would we detect it? How would we characterize it? Would it be porous? Would it be with a core of iron? What angle would it enter in? So at the beginning of the week of the conference, Paul showed us, who designs those scenarios, would give some data, and along the week, decisions would be made as to how to protect the Earth from that asteroid impact threat. And then in 2016, now you have those national institutions being created. So at the US level, you had the US National Near-Earth Object Preparedness Strategy and Action Plan drafted, which turned into the Planetary Defense Coordination Office, created the following year in 2017. And at the European Space Agency, their own Planetary Defense Office was created 2 years later in 2019. And you can see that this management is really young. We're in 2022, we're talking about offices that were created 5 to 7 years ago. So summary of the policies that you can see here: international level, the national level, as I explained. And in terms of economics, it's interesting to see the evolution of the budget in terms of planetary defense. And you can see in 2020, it's all hashed. Why? Because it also depends on what you include in your budget. Here, with that data, it's because they were talking and including into their budget the DART mission. Is the DART mission, yes, it's in some ways it's a planetary defense mission. We're going to, impact an asteroid, the moon of an asteroid. But is it planetary defense research? Kinda. So that's why it's hashed. But you can see this spike. And every single time NASA puts more money into a project, ESA puts more money into a project as well, because also the ERA mission led by ESA was in parallel to the DART mission that you can see here. So why does this field of planetary defense led by scientists try to manage itself, try to construct this management structure? Well, they want to improve their preparedness, that makes sense, improve the decision making, because at this point in the presentation, we still don't know who would make decisions if we were to be impacted by an asteroid. And the most important is to prepare for long-term national and international policies, because we need to design things that may be helpful 300 to 400 years from now, because we may hopefully very well not be impacted for this long. I wanted to show you a little bit, just an example of decision-making structures. This is within NASA. You can see that under NASA, you find planetary defense and you find SemPage and I1 representatives under the planetary science division, and under that, under the planetary defense officer. So on each branch, you will have a SemPage and an I1 representative. And I will always invite you, when you jump into a mission and work on any sort of scientific research project, to go find those charts so that you know how the decision is being made above you. And that is a quite interesting thing for the general public, which is the intergovernmental planetary defense decision-making structure. So following this graph, you know who will be informed and when in case of an asteroid impact threat. So you probably can't see it because it's kind of small, but it pretty much tells you that, is it going to impact us? Yes or no? Is it going to impact another country? If it's going to impact another country, we need to reach out to through the State Department to offer help to the other country. If we are the one impacted, how large is the object? And then you get from informing NASA to informing the Office of the White House to informing other departments, including FEMA, the Federal Emergency Management Agency. And then you have this little light here that tells you that you should also inform the public. Here we go. And in terms of structure at the UN level, you actually have set data as to when one would be activated. So I1 observes, SEMPAGE prepares for mission and discusses, and we meet twice a year. But if we were to detect an asteroid that had more than a 1% chance to impact the Earth, and that was more than 50-meter wide, and if you remember the previous slide, more than 50-meter wide, that would mean at least national effects, then SEMPAGE would activate a plan and would start the steps to be able to push away this asteroid. And so now, yes, scientifically speaking, there are ways to push away an asteroid. Now we want to make sure that at the decision level, it is feasible. This is why SEMPAGE, a group of scientists, decided to create its own group of international lawyers to look at the ways in which their mission would succeed and ways in which the international law would not potentially block them. So in 2014, they created the the SEMPAGE ad hoc legal working group, which I lead. There are 13, SEMPAGE has 18 members, and we have about 15 international lawyers as part of our team, with representation from everywhere. We did have, it's not listed here because they were not part of the first draft, but in the second draft we had lawyers and colleagues and friends from Russia and China as well participating in this report. And what this report says is when you push away an asteroid, you have problems. I'm checking the time, and I'm over time. Yes, I will try to be short. You have problems of liability for damage. So if you push away an asteroid, the main issue is that you have absolute liability after having pushed it. Meaning, if Belgium were to be impacted and did not have the capacity to push away this asteroid, potentially it could turn to NASA or ESA and ask for help to have the technology to push it away. And then NASA would say, yes, but if I push away this asteroid and somehow something goes wrong and a piece of it falls onto China, I have absolute liability as to everything that would occur in China, and I would have to pay China. So the work there is to create draft and documents so that they would, and waivers, so that agencies would have an incentive to help smaller countries when they needed to push an asteroid. Obligation to inform and to act, that's very important. You have to tell your population. If your country is detecting an object that is threatening to your country, you have to warn your population. And if you've seen Don't Look Up, there is this whole debate as to when you got the information, how long do you need to inform your population? Law will tell you as soon as possible, but we do not have specific delays for that. And you need to consider the decision bodies. So who makes the decision when you were to send something to push away this asteroid? In terms of mitigation methods, there are plenty. The main two are kinetic impactors, meaning that you're literally sending something to impact the asteroid to push it away. And the second one is to use a nuclear device, and so a nuclear explosion close to a nearest object or on and below its surface will create radiation that will vaporize the surface of material and eject it at high speed. The pressure wave from an explosion will then push pretty much the asteroid away. And that seems to be, with nuclear impactors, a really good potential method. However, international law, in Article 6 of the Outer Space Treaty, it is clearly stated that state parties to the treaty undertake not to place in orbit around the Earth any object carrying nuclear weapons or any other kinds of weapons of mass destruction. Install such weapons on celestial bodies or station such weapons in outer space in any other manner. So if you were to think, well, potentially an asteroid could come and impact us, let's put a nuclear charge around the moon or on the moon, just so that it's ready to send to the asteroid. Completely against the law, and it makes sense because you can imagine that easily this charge could be used to be dropped on Earth, and that's what the law is trying to avoid. And then there is this question, vocabulary question of weapon. Yes, but it's to push away an asteroid. It's clearly not a weapon. It's a nuclear charge. It's not a weapon. Well, by definition of the Limited Test Ban Treaty of 1963, it prohibits nuclear weapon test or any other nuclear explosion. So it's the question of, do we call it a weapon, do we not call it a weapon, doesn't change anything because it can be used as a weapon and nuclear explosions and are banned in outer space. So in conclusion, so those are the conclusions of the Limited Test Ban Treaty. For the others, it tells you that a state has the right and obligation to try to protect its territory and its population, but however, there is no obligation under international law to assist other countries, which is why we want to create those incentives and those waivers to make sure that if there is a problem, larger countries or countries with more technology will be able to help smaller countries that may be impacted. Same thing for damage. We went through this. And the general question that I get a lot is, what if a private company goes and pushes away the asteroid itself and saves us all? Under international law and the Outer Space Treaty, non-governmental entities are under the responsibility of the country. So whichever private company does anything, it will depend on the country they're from. And finally, who would make the decision? Well, there are ways to supersede international law, and sometimes it may be necessary. If there is an asteroid coming towards us and the only way is to use a nuclear device, potentially it would be necessary to put aside the Limited Test Ban Treaty and the Outer Space Treaty, and this decision to supersede international law, the only council that can do it is the United Nations Security Council, and they need to have 9 votes to be able to pass that decision. To finish, to know more, if you are coming to Harvard and MIT at any point, lots of research available online. I lead the Space Consortium, which is a sort of network that puts together all the resources of Harvard and MIT, and several of us are working on planetary defense, so feel free to just visit the websites. You'll find a lot of research there. We do a Space Week every year, so join us for that, and it's also fully available online. And if you're somehow now interested in space law, there are plenty of institutions that specializes in space law and in those themes. So you can find them at the University of Leiden in the Netherlands, the Space Policy Institute in the US, McGill, the University of Mississippi, etc. Conferences that you can go to, COSPAR, the IAA, IAC, plenty, so hopefully you'll be able to access those slides to get that. And finally, we do a Planetary Defense conference, and as I told you, we rehearse those scenarios. If you are interested, there is now the next one is in 2023 in April, and there is now and the press talks about us, and there is now 3 sessions for social scientists if you are interested in talking about disaster management and response, public education and communication, and the legal, policy, and social aspects of planetary defense. Those are also scenarios that you can do at home, so they share every year the planetary defense scenarios online if you just want to rehearse and see what happened. And on that note, I thank you for your time and attention.
And this is a perfect segue to our 3rd speaker, who is going to join us virtually. So we will wait for her to join with Zoom. And she's going to actually, I specifically wanted to include this talk. It fits or builds on the previous 2 talks, but mostly because I'm jealous as a geologist and oceanographer at how effective NASA does their communication with the general public, and that's going to be the topic of our 3rd talk, and our speaker will introduce herself and we'll take it from there.
Great, thank you so much, and I do hope you all can hear me. If people on the stage can give us
we can't hear you.
You cannot hear me. I'm not muted. Oh, there we go. Can you hear me now? Yes. Welcome to remote everything. Hi, everyone. Thank you all so much for having me. I'm Aries Keck. I am with NASA Communications and Earth Science. I'm going to share my presentation. So I think we've all suffered through these, but I think I hit share screen and hit desktop. Maybe I need the rights to do that from one of the presenters. Okay. Is that working? Can you see slides?
Can she share on her own computer?
That was the idea.
Just a second, we'll
No worries.
figure out. Oh, so let's wait. So it's a webinar. We're not sharing anything here.
I'm in the Zoom webinar, yeah.
Yes.
So, okay, just mentioning, and it does say,
You should be able to share your screen.
Okay, let's try this again. Hit share. Okay. Thank you all for waiting, I don't see it up there either still. That being said, I don't want to waste everybody's time.
We actually see it.
You do?
Yeah, we saw your presentation.
Okay, great.
Go back to whatever you did.
All right, so there we go. Do you see a slide with people on it and my name on it?
There, now it's
Fantastic.
fine, perfect.
All right, so now of course I'm flying blind and can't see you all, but hi, thanks for having me. So this is a graphic of all of the existing NASA science missions and some upcoming missions.
Sorry, you just went out of it.
It went out of it again?
Yes.
You saw the previous one, right? Doot, doot. Do you see a big slide that says Science Fleet?
Not yet, so go back to...
When I did share screen.
Yeah, share screen like you did before, and then you can go to presenter mode and move your slides.
Yes. Okay. You guys don't see anything though now, do you?
Well, we have one of our tech support right here.
Okay. Let me know when it's time to just talk, because I can do that for sure too.
Well,
I know you can see me. Hi, everybody. I could turn the other computer around and hold it up. Go a little old school.
Okay, I was told that they will share we can share your PowerPoint from here.
Great.
And when you need us to change the slide, we'll do that. Just say next slide.
Great, great, great. Thank you all. And thank you all for your patience with the technology on this. And I see, yes, thank you. Go to the next slide. Good 2-minute introduction to this talk. So if you go to the next slide, that's going to be a graphic of all of the existing and some of the upcoming NASA science missions. This is not even the astronaut portion of NASA, but this is the science division. This is the Science Mission Directorate. And you can see there the vast amount of science missions that NASA has up there. The previous speaker talked about some of them, DART, et cetera. NASA is a very unique federal agency. We're a federal agency like the post office or like the IRS, but we have people running around with buying t-shirts with our logo on it and talking about it. So we have a very engaged core fan base. And then what we try to do in communications is make sure we feed that core fan base, definitely, but then also try to bring people in who are sort of adjacent to that. If you can go to the next slide, that's going to show you all of the Earth science missions. And this is the Earth and Sky panel. I work in Earth science. This is the fleet of all the missions that we have up just looking at our home planet. There's a few reasons why NASA has so many missions studying Earth. For us, all of us, it's pretty much the most important planet. It's the one we live on. It's also a very good practice area for doing missions. If you're going to study the atmosphere of Jupiter, you might as well do a mission that studies the atmosphere of Earth and see how it does in space. And that's how we do many of these missions as well. This is more than, you can see there's more than 20 here. There's not just individual satellites, but there's also all of the instruments we have on the International Space Station. And actually, I would say all of this data is also confirmed with ground stations and on the ground areas. But the part that NASA has that makes it unique is this unique space-based view. Another way that we sort of feed our audience, and you can go to the next slide. This is what I was mentioning a little bit about instruments on the space station. I believe that's Canadarm, and that's looking down at Earth and with a hurricane or a cyclone shown there. NASA not only has very unique views of the Earth, but we also have a very long history of data collection. And all of that data is free and open to the public. There was a very brief time to commercialize some of that data, and it luckily, I think for the good of mankind, it failed. And so all of the data is available. So we have this tremendous amount of data pulling around. And we look to use it in many different ways. If you can go to the next slide, And this is supposed to be so this is one of the longest serving missions that NASA has, full stop. It's an Earth science mission called Landsat. And we have had Landsat up in the air since just a little bit after we landed the man on the moon. The first satellite was called ERTS. It got renamed Landsat. That launched in July 23rd, 1972. And you can see with this graphic, we've been adding to Landsat since then. Landsat images are the basis of Google Earth. You know, if you go to Google Earth and zoom in on your hometown, some of the images that you're zooming in through are Landsat images, and then they go down to the commercial data. So in studying Earth, having this type of consistent, long-term comparable data set is invaluable. You know, it fits into how scientists can measure what we're doing on our planet. This is just the Landsat mission. Don't get me wrong, there's a lot of other missions, but that has been the basis for sending up many other missions of how we collect data about the Earth. Also, this year is the 50th anniversary of Landsat. We're doing all kinds of celebrations, and hopefully about a week or two, you'll see about the handoff of the most recent Landsat mission, Landsat 9, which launched successfully. And by handoff, it gets handed off to the US Geological Survey because they run the data collection once the satellites are up there. And then we start looking onto the next Landsat mission. If you can go to the next slide, please. And so one of the things, my part of this talk had a great long title, and I really loved the title I got. It was given to me, which was, the subtitle was Community Building and Communication. So I mentioned earlier how NASA has, for communications purposes, a fan base, and a pretty rabid one. But we've been tried to focus on doing is how to expand that, how to take the people who are inherently interested in NASA and get them interested in all of NASA, or how do you take people who are fair, you know, have positive views of the agency, but no real idea what we do or what we do with Earth science, and get those circles to be ever widening. One of the programs we're really successful with has been called a NASA Social. If anyone is as old as I am, you might have been, they were called tweet ups for the first two of them. The idea was to kick off bringing social media users behind the scenes to launches and various NASA events. It was a very new idea when it started, and it really took off, and it really worked to build up that community. We have now done NASA social events, not just for launches, like you can see a rocket in the background of all those folks, but we've done them for behind the scenes for our balloon program. We have these giant weather balloons that carry scientific instruments up, and we take people into the labs that build those. For the recent amazing images that James Webb just sent back, and that were quite really below even our socks off on how well those images looked and how well they did out in the communications world. We had a 2-day event where we brought people in, walked them through the labs, had them talk to people about what they're working. And the idea there is that every attendee is doing what that woman's doing with her phone. A very successful NASA social event is no one looks up. They all look, they're listening and nodding, and they're taking pictures, and they're typing frantically on their phones. And we've done a few of these events also with really specific audiences. We've done ones targeting people who are into physical fitness and worked with some, trained like an astronaut. We've done some particularly just for artists and digital artists and fine artists with James Webb, and brought them in when James Webb was being built up in NASA Goddard. And they committed, many of them, we gave them 2 hours to just look at the instrument behind the glass, but to look at the James Webb Space Telescope. And at the end of the day, we had, poetry readings and someone playing guitar. And then a few months later, people were doing art. It's just another way to really tapping into people's curiosity, get them excited and engaged about things they will never touch, far off galaxies, and also get them to understand sort of the bigger picture of what NASA does. If you don't mind going to the next slide. So NASA talks about, community building and communication. So in communications, we, the NASA, the royal we of NASA, have our own channels where we publish things. You can see some of them here. We also, I mentioned Twitter, we also put things in Twitter threads and things like that. The idea here is this content is written for the general public to read at any point in time. The far left one that says perspective, so that's specific to my program. I'm in NASA Earth Applied Sciences, and literally that is what we do. We take the data that I mentioned earlier, those long time scales of data, all the information from all those many missions, and we work to put it into the hands of people who can use it. People who regulate mosquitoes in New Jersey, water resource managers, other people who can take this data and make better decisions because they have NASA data. And this is a big lift at times. You know, the data comes down from satellites in certain formats. It comes down in certain time periods. And so a lot of what we do with applied sciences is listen to different groups about how they might be able to use NASA Earth science data, and then often work with them to create tools to build out that data. And then if we can go to the next slide. Fantastic. Thank you so much, whoever's running the slides. Really, I was just going to have to monologue. One of the things with Earth science, this is part of your Earth and Sky track at Goldschmidt. I know it's the last one on the end day, and thank you so much for anyone who's still here and listening. But the connecting this back to indigenous theory and thought, NASA has now, and most of Earth science, and I've been in Earth science communicator most of my career, is coming around to what it seems to be what indigenous peoples have a view of the Earth, in that seeing it as a whole system. It's a very interconnected system. Science normally is very reductive. You look at a cloud, and then you look at a smaller cloud, and you look at a, you know, or you look, sorry, forest. Look at a forest, and you look at a leaf, then you look at one individual leaf. This is a systems approach. And one of the ways NASA's leaning into this is that we've just announced back in May, the Earth System Observatory. And this is a way of looking at all those Earth science missions we talked about earlier, but in a way that connects them, that goes in this a literal circle of the content that goes from bay to bay. Each science in the observatory is uniquely designed to complement the other satellites. And they work in tandem to create sort of a holistic view of Earth. That seems to be very equivalent to what I know, and I don't know very much at all about how indigenous people view Earth, but what I've seen from what they do is they're connecting it and looking at it as a whole system. And so this is what we're hoping. I feel like NASA Earth Science is sort of coming around to an idea that's older than NASA itself. And so that is generally how we're putting things together. And we can talk a little bit more in the Q&A. We have an Indigenous Peoples Project in the Applied Sciences program. I think other people at this conference have already addressed that, and we can talk about that as well. But with communications, in reaching out to everyone about what NASA is doing, we're constantly, if you can go to the last slide, we're constantly trying to not only tell people what we're doing, but we're also trying to listen to see what the community wants, how they can use it differently, and how to open the door to get even more people to be excited about our planet Earth. Thank you so much.
Thank you, Eris. And yeah, please don't turn your camera off so you can be here with us on the panel. And Nancy, if you want, we would love you to join the panel as well. And you can introduce yourself as you come up. And as Nancy's joining us, this is the time for us to ask questions. These very interesting, diverse talks we had. To ask questions, you need to go to the microphone so the people on Zoom can see you, can hear you. And our student helper will watch the QA on the webinar for people who are online, and will also go to the microphone and read these questions if they are there. And as you're doing that and thinking of questions to our panelists, I'll start with one question. Again, I noticed a theme that was in all these talks about the challenge and desire to communicate and to share this knowledge with different audiences. And if each of you can say something about effective ways of doing that and challenges, that will be great, starting from, talking to Hawaiian youth about their historical indigenous knowledge, and all the way about risks, or that new word that I did not hear about before. What was it?
Scotomization.
Scotomization, and so on. So let's start. And thank you.
Yeah, there's lots of challenges. Actually, one of the main ones is trying to get people off of their phones, not talking to you guys. I mean, kids. Not calling you out right now, but yeah, because their world really revolves around what's happening on the phone and not actually interacting with the environment. And our cultural epistemology is that we're descendants of the atmosphere, we're descendants of the earth itself, the descendants of all the animals, the plants, the fish, et cetera, et cetera. And so therefore it's more about relationship building and constantly re-engaging and engaging with our surroundings. And that's not something that happens today. So I would say that is kind of one of the major challenges that we have.
And what do you do in your organization to address that?
What are we doing? We have workshops. We train the trainers. We do online things. Actually, COVID was a good thing that happened to us because it forced us to sit around and think about innovative ways to reach different people and different things. So we're not things, but different communities. And yeah, I think we have more of a global reach now that COVID has happened. And so, yeah, and there's actually more interest outside of Hawaii than there is in Hawaii sometimes. So, which is good. And it helps to connect and sort of see value in each other and different ways of knowing and how it can actually contribute to what's happening today and bring a holistic view to practices that have been happening for a while without indigenous knowledge. So it's, yeah, that's my opinion about that. Yeah. Thank you.
So from my side, yes, to talk again about a little bit about scotomization, there is a way to communicate and it's necessary to communicate, and the effect of scotomization reminds you that if you end up in areas and you go tell people you need to leave your place, they may not be able to absorb the information because they've never heard of it. That gives us an incentive to do much more communication, not only because, I don't know, good PR or it's interesting knowledge, just learn about it. No, because if there is an emergency, you want people to have had at least somewhat of a small incentive, somewhat of a small piece of information so that they can understand what's going on. That's the main point in terms of planetary defense, to make sure that there is this knowledge. The problem is, and you didn't see it in my slides because I didn't show you too many of the slides from our exercises, is that it can easily create a panic if you go talk to people and you explain that an asteroid could impact us. We keep on repeating that the chance is minimum, that we're just doing prevention, but in every single slide on the exercises in big and red letters, we need to say and remind everybody that it's an exercise, because you do not want to just create panic, or people who children who are 5 to 12. Yes, it's great to talk about planetary defense, but you do not want them to go at night and ask their parents if they could die during the night because an asteroid may impact them. So it's, in terms of those, life-ending threats, it's important to find a balance, and on the one hand, do the necessary communication so that people know enough about it, so that when there is a crisis, there is an ear and they understand what's going on. But at the same time, you didn't want to use planetary defense to make, create panic. And you can see that, I've seen it already in the media, already about Apophis that is coming in 2029. I mean, coming. near us, not on us. And the way they talk about this threat and, oh, you need to raise funds for planetary defense purposes because Apophis. And I'm completely against that strategy because it's using panic to raise money, which is absolutely not what our domain wants to do. So on the other hand, how can you reach people while, enjoying things and make things fun? We created a film festival because movies are wonderful. At least that's my point of view. And so we showcased Don't Look Up and invited the Planetary Defense Officer of NASA to comment on it. We organized other films. I think we had Deep Impact and Armageddon, which, if you haven't seen it in a while, kind of watched like a comedy nowadays. So it's kind of nice to try to find other artistic ways to involve the audience. They watch a good movie, and at the end of it, you have a panel of experts that explain the topic and why it's important.
Perfect. And Nancy, would you introduce yourself, and then we'll go to Aries.
Sure. Hi, Aries. It's great to see you on the computer screen. So my name is Nancy Searby, and I work with Aries, and I am in the Applied Sciences program at NASA and manage our program that's designed to build the skills to use all that satellite data in the world. I don't have the money for that. My budget isn't big enough, but the aspiration is there. And so we have a training program called RSET, free and open to everyone around the world. Used to be hands-on and online. Pandemic went all online, so we reach more than 100 countries every year. And then we have a way of learning, which most of you probably realize, you learn best when you're doing things as compared to listening to things. And so that's our Develop program. All letters, capital Develop, NASA Develop. If you go Google, you can find it, which is a 10-week experiential learning program for teams of 4 or 5 people, 18 and up. Can be transitioning professionals to working with a user to address a particular issue that they're trying to apply NASA information to address that issue. And then finally, we have things like our international development program called Servier, working in 5 parts of the world, as well as our Indigenous Peoples Pilot, which Aries mentioned, where we are working with Indigenous communities to understand needs and gaps to train them on how to use NASA satellite information for better land management decisions. And so, your question about how you reach people, I think Aries and the COM team and our program actually are, side by side working a little bit differently, and sometimes and always together as well, of like different target audiences. So for me, it's important to think about those target audiences and how you reach them, and then be a little more specific about that so that you can really communicate in a way that's useful for those target audiences. We have another program which we haven't talked about called Globe, NASA Globe, which I recommend if you haven't seen that. There's a bunch of experimental protocols that are used by anyone from the public. It's growing more and more in the public space, but it's been traditionally focused on the educational space. And I don't remember how many countries they engage with, more than 100, I think, across globe as well as many schools here in the United States, if you haven't heard about it. So there's lots of different techniques, and I don't think anyone works particularly well. Maybe I'll just give you a final reflection after being here with you, Adina, and enjoying your session. I think that the challenge that I'm going away with is to think about holistically how you take a place-based knowledge and perspective to immersively engage. And so, I come from the geospatial side, so sitting in with the geobiochemistry work really brings back some really old cobwebby memories from my educational days, but I am not doing that work now. But you're at such a completely different spatial scale, right, than what we're used to working. But how often do we talk to each other across those spatial scales in a place? I don't think we do it enough. And so for me, I know that this is two societies working together on Goldschmidt, but for me, I participate in AGU, not traditionally Goldschmidt. But it's an interesting question about how, if you really believe the presentation we heard today at plenary, 2.5 years, take that away. Whew. Like, I'm still reeling with that idea that we have 2.5 years. That is just nothing, And so how do we more holistically across all of our disciplines really, band together to make the big impacts and to communicate to people? You talk about asteroids and not being afraid, I mean, we laughed and were afraid actually because that was a parody on climate change. Don't look up. And at first I was really sad and went to bed. And then I have 17-year-old twin boys. I went up and told them the next morning, you have to watch this movie. Because the kids don't get it either. I mean, so I think it's a real challenge for us to think about, you don't want to scare people. On the other hand, maybe we should scare ourselves, right? When it comes to climate anyway. Okay, Aries, you want to finish it up with something more positive?
No. Well, hey, that's kind of, oh, go ahead.
Before you go, Aries, I just want to mention one thing that Nancy has not, that NASA is also one of the big supporter of this session here. So thanks to her, we're all doing this here.
Yeah.
And now, Aries, you go.
No,
for her program.
No, thanks for having us. And it's hard to follow Nancy. So two quick challenges to yes and to everything she said. In communications at NASA, a challenge we have is getting people who are interested in rockets to be interested in the planet they're standing on. And I threw out some of this, I feel as I say some of these phrases so often, I need to remember, the closest planet we have is Earth. This is a planet that can be studied right now. We do a lot of that. It's everybody gets siloed very easily, but what we try very hard to do is come up with the Earth science angle to pretty much anything that's happening. And NASA Communications does do a fairly good job of opening those doors of if something big is happening in the astrophysics area, which just happened, we came up with some ideas of what we could do on the NASA Earth Twitter account, and they will do the same for us. And so there's a nice cross back and forth. The other big challenge we have in Earth Science Communications that Nancy alluded to is the information, the heat, the things that are happening right now. There's, trying to make sure that we aren't unduly scaring people, but also making sure that we're not being Pollyannas about things either. One of the things that we can do with NASA and Earth science, though, that does make me optimistic is there's so much more we can do with Earth science information. We can't necessarily cool everything off, but we can see where things are getting hotter and get that information to people who can make decisions, hopefully better decisions as we go forward. So that's the two big challenges we have. One, how to get the rocket people to care about planet Earth. And two, how to keep all Earth science communicators focused on a positive, we're doing something, this is what we're able to do. This is the data we're getting. It is a place where there is action happening. And I find that very soothing when it comes to talking about climate change.
Yep. Questions from the audience?
Aloha, my question is for Kumukale. I was wondering, so I've heard some Hawaiian words for weather is anila and climate, aniau, and I've heard ho'ohulianiau for climate change. But I was wondering if in your research you found any other maybe older terms or phrases for each of those things.
Thank you. Aniau, Anila, and Ani, what was the other one? Anyway, that's okay. Those are all new words that were created. Yeah. And I'm not saying that they're bad words. They're actually words that had to describe what was happening. So they're a conjunction of different Hawaiian terms that were put together to sort of articulate what's happening from a Hawaiian point of view. But yeah, we have other words like ao and of course, they're all not coming to my mind right now, but we have many different terms. And then we also have different philosophies about change in climate. We actually believe that climate is always changing. And so therefore, we should be mitigating our own personal responses to those things. And with the idea of thriving, right? So that's basically what you see iterated over and over again, reiterated over and over again in different stories and different chants. That idea of, well, if it's not working for you, going with the flow might not work. So you might have to get on a canoe and leave, which is actually a response to climate change. in the past. That's what people have done. So we do have stories about that, big flooding, you know, too much salt in the water. You know, there's all these themes about flooding in the past. So and finding new land to survive. So yeah, I don't know how to answer that, but that's how I'm going to answer that.
Yeah, mahalo.
Okay, thank you for asking.
Hi, I'm Margareta. Thank you so much for the talks. They were really, really interesting. My question also is to Kale. So you talked a little bit in the beginning of your presentation how you focus more on the chants because they're more, I guess, they don't change as much, but I'm interested in storytelling and if there are any contexts that would benefit from this adapted quality of narrative.
Yeah, for sure. Yep. Thank you for asking that question, actually. And what happens with narratives is that what we can see from looking at the different narratives is they're trying to describe what's happening in the chant as it applies to them at that moment or at that time or at that present, and what they're thinking about how to innovate and move on through the future. So I don't personally like the word traditional because to me it sort of gives this impression that things just sit somewhere and it's from the past and it doesn't move and there's no innovation at all. But that's not true. So what you see in these stories is this intergenerational transference of knowledge that innovates, but uses the chance to say, this is the data, this is what happened, and this is how we responded to that. And we can always point back to that, the original. In that way, chants become timeless. And so they keep sort of moving along with us in time, and intergenerational knowledge gets added to it. The stories change, innovation goes into it. Mitigation happens too as well, but the chant pretty much stays the same. So we know that the climate will always change. We know that water will someday not be available to us. So therefore, these are some of the things that happened in the past. And so we can look to those chants to give us some answers for survival. Thank you.
Hello, Danica Mitrovic from Royal Netherlands Institute of Sea Research. First, I really have to thank you all, and also to thank the people who organize these sessions at the end of every day, because it's been the best end of the day for people who for myself personally, but I guess also for other people participating at the conference. So I basically have two questions, if I'm not going to take too much time. The first one would be to the first speaker. In your presentation, you mentioned so many words, of course, and I don't know the Hawaiian names, but you said time. When you were speaking of weather, you also said time. And in one of the previous sessions, one of the speakers also made this sentence of Hawaiian indigenous people and their reference to time and how they deal with time. And I remember they said Hawaiians live in the present with their back to the future and looking into the past. So I didn't get a chance to ask Dan, and maybe this is not the best question for you, and then I apologize for that, but I would like a clarification on how indigenous people of Hawaii look at time, deal with time. What does that mean to them?
Mm-hmm. Yeah, thank you. Sorry to my panelists, but yeah, time is really important for us. It's because everything has its own time, and we also have our own time with trying to figure out how our place in space actually can align to moving towards. It really is about thriving and survival, and finding ways in which we can move forward. But a lot of our, I'm going to refer back to chants. A lot of our chants, a lot of our prayers are actually phenological data, lots of it. So it'll refer to what's happening in the moon, the phase that the moon is in, the season that it's in, and then it'll refer to a weather system that is occurring that we can actually see and know that those two things go together. And then it'll refer to a growth process or animal, fish, or plant, or whatever it's doing. And so when we talk about time, we're talking about phenological time and all of the seasons that sort of kind of meet together. And this way we know that we're on time. That's how we keep time. And if those things are not on time, why aren't they? What's affecting that? So that's a constant thing. And then, and is there climate change that's changing that today? And that's kind of where we're at today. A lot of our research now is just going back to see those phenological things that were noted in chants. And one of the fortunate things that we have here in Hawaii is over 1 million pages of newspapers, Hawaiian language newspapers that start from 1834 all the way to about 1970s. And so it's over 100 years of information that Hawaiians wrote with a sense of urgency about these changes and about these things that they were witnessing. So there is a lot of data to be collected, actually, to refer back to those different changes. But anyway, that's how I'm going to answer that question. So time is important to us in that way. It has to do with seasons and cycles.
Thank you very much. And my second question was actually to the second panelist. I would like if you could clarify the term of liability, because that just wasn't something I was expecting. So in my imaginary scenario, if Sudan, for example, becomes threatened with the impact or something, and it engages ESA or NASA or whoever can help, and then there is a possibility of something from the deflection of this thing going to Europe, to one of the central countries in Europe. How will Sudan deal with that? How will just the concept of liability, I really wasn't expecting that. So that's in the international law, right? Are you guys going to change it? I'm just baffled.
So you wouldn't want it changed. Like, absolute liability is important, because that means that when a country does something to another country, there are consequences. So you wouldn't want that gone. However, you do want waivers in those specific, very exceptional circumstances, so that you create an incentive for a country to come and help. So in the example that you gave with Sudan and a country in Europe being impacted by this, maybe, I don't know, a piece of the asteroid would detach and fall. Again, I always take Belgium. Sorry, Belgium.
That's because you're French.
Well, then you would want, let's say, the United States or Russia or China to help. And for them to help, you would want to write this waiver and for everybody to agree, sort of as a contract. I'm coming in and helping, but whatever happens, of course, I'm going to do this mission to the best of my abilities. The goal is for the entire asteroid to be moved away. But if something happens that could not be predicted, then I will not go under this absolute liability, which would make me have to pay for everything that potentially would be destroyed. So that's why waivers are important. That's why those kind of, legal groups and policy groups, understanding where decisions are being made, who are making those decisions, and what legal tools do you need so that you have those incentives to help if such situation were to happen.
Okay, thank you.
Are there, sorry, I need to follow up on this question. Are there international organizations that are like an international FEMA that collect money, or there's commitment from rich countries to put some funds together if something like that happens?
Well,
because somebody will need to cover the expenses or deal with the disaster.
You would imagine that most space missions, so many space missions, are not done just by one country, right? You have experiments from different countries. You have ESA in and of itself is, in a way, just pulls money, and you have ESA missions. You do have, French mission, Italian mission, German missions, but you have ESA missions. So in that sense, you do have already systems where money is pulled together. If we were, there was a need right now, we're seeing with the DART mission, you have a NASA DART mission and an ERA ESA mission together on the same, combined sort of mission to push, to impact, I shouldn't call it Didi Moon, but it's my way to remember it because it's the moon of Didymos. And so one way to do that, you wouldn't create an international space agency in the space policy world. A lot of people discuss this. Would it be possible? But then in terms of decision making, how would it be feasible? It's a whole debate. But you already have the United Nations Security Council that would make a decision that's already in place. You would have, for those waivers, you do have those international group at the UN level. You have the technical and the legal subcommittee. We are a legal ad hoc working group working for a subgroup of the technical subcommittee. So you do have different layers and places where you can discuss of this and design plans. That's the goal. You plan, you design the plans, and then to put it in place, you would have the International Court of Justice if there were any conflict.
Thanks. Other questions from, go ahead, Tom.
So I think this question's for Elisa. You focused on sort of these planetary protection defense components, but I'm wondering about, if you will, protection of the dark sky. I know in the last couple of years, the Starlink satellites from SpaceX have been an issue of, preventing people from necessarily seeing the dark sky, the night sky. And so what are the legal frameworks available to sort of regulate that? I mean, a lot can happen on the ground because most of the dark sky problem is our lights, but I'm just sort of curious.
It is incredibly important. I will say right now, I'm not a dark sky expert, so probably my answer will not have as much content compared to when I talk about planetary defense. But for the dark sky and Starlink, I discussed this on a personal level, but also throughout those working groups. So the space law community has places where it gets together. We have space law symposium, we have space law conferences, and night pollution, light pollution is discussed as well as space debris. And those two are brought up when we think of Starlink, because we're thinking of thousands of satellites and we're thinking of potential future space debris, even though nowadays the law enforces that you have to have a re-entry plan when you send anything in space. So when you see all those Starlinks and some people from the general population being worried, oh, that's just debris, it's just going to create debris. No, every single one of them has to have enough fuel to be able to re-enter, and before their launch, they had to prove that they would be disintegrated into the atmosphere when they re-enter. So can some of them dysfunction and then just stay there, and the program to bring them down, dysfunction, that's obviously a possibility, and thus the problem of space debris still exists. But in terms of the light, what I was told, at least by SpaceX lawyers, they have a whole space law team, and they do work directly with organizations that protect the night sky, because it was so important, and they have all those debates. And as I understood it, they made it so that the light from those satellites would not happen during the dark sky, during the night. So you would see it is at a height where you would see it at the beginning of the night, or you see it at dawn, but during the night sky you wouldn't see it. Is this something that's going to be applied to all those small satellites that are sent everywhere? I do not know. There are more and more conferences also about space ethics that discuss this and invite people from the private space sector to have this discussion. And I prefer to believe that it's not, the private space sector are the bad guys, because you have companies that are surveying the sky and you're using that data to help agriculture, etc. So having them into the discussion rather than continuing a narrative where the private space sector is polluting and the astronomers are suffering and the general population cannot look at the sky anymore. Creating those divisions is quite harmful. So those conferences and bringing these agents together and discussing how to make sure that, yes, there is still a continuation of development of technology, and Starlink will, help, I think, with internet all around the world, but at the same time, not disturb populations who are relying on those dark skies for their traditions and their practices.
Yeah, I have two anecdotes to add to that. Just the week before this conference, I was here in Hawaii with a group of youth from LA that came here to talk to Hawaiian indigenous youth in a camp. And I was amazed that most of the kids from LA never saw the stars at night. They said, "Oh my God, what is this?" They were so surprised. There's just so much light in the city that they never see the stars. And also they spend most of the time probably in front of the TV and don't go outside to see them. But it was, to me, it was like, wow, really? You've never seen the stars? Then the other anecdote, which maybe Nancy and Aries can, they know more about that, but I remember seeing images from NASA satellites showing changes in the lights at night because of halogen versus non-halogen lamps. And you see, it's so amazing. The colors change from like this yellowish to complete white. So you can see which streets are lit and where they're changing the energy, the bulbs they're using. And it's just striking to see that. It's just so clear. Even within like one street versus another where they're making these changes. So
Yeah.
these are amazing tools actually to teach with, these images.
If you go to NASA has an amazing new visualizing instrument called VIRS, VIIRS, and we did a Earth at night image where we pulled, clouds were it was a composite, because as you go around, you're going to hit clouds. So once they finally got enough cloud-free views, we stitched it all together and turned it into both a flat map and then something you could zoom in on. And it was startling how bright the lights were. And also it was fascinating and what it really showed was human activity on our planet. It showed how certain areas have vast amounts of lights at night, other areas don't at all. And it uncovered a lot of things that we didn't even expect when we were pulling those images together when it was announced at AGU, I think about 5 years ago. You can see fishing boats in various international waters because they use bright lights mostly for squid, but for actually fishing. And the images we showed turned out to show boats where they weren't supposed to be boats, and there was a lot of that type of information that was pulled out of what we called Earth at Night, or it's also called the black marble or the night lights. And so it's an interesting idea, and it's interesting to see if these dark sky areas catch on, as I hope they do. I'd love to see differences and changes of these satellite passes over some of these areas. It might be the resolution might not be there, but it definitely really drove home the effect of human beings on the planet for many different people, not just in, here's the East Coast of the United States, but if you look at the difference between North and South Korea, I mean, there was a striking difference as we went through it. So it's a fascinating teaching tool for talking about, how even on this very base level, how humans change our planet as we live on it.
Yeah, no, these images are amazing tools for teaching. There's also during the night images, there's the burning, the fires.
Yes.
People that don't actually have lights, you can actually see little campsites.
Yeah,
Which
you can see campsites, you can see wildfires. We could see a lot of burning, off-gassing from oil refineries.
Yep.
It was, I worked on that project, I remember it distinctly because we worked over Thanksgiving. I remember sitting there, eating Thanksgiving dinner at Tupperware where we were working on getting that pulled together because AGU has their meeting in the beginning of December. And we were trying to come up with storylines about what we could point out of these images. And those were just a few of them that we were able to talk about. Well, we can talk about any of them, but those were just a few of them that we came up with in seeing fires too at night. It's really fascinating.
Any other questions from the audience? If not, I have a question for Nancy and you, Aries. As a professor, I teach a lot, and I, like both of you mentioned, or actually all of you mentioned, it's really important if you want to be effective that the data that the students are using is close to them. So it's place-based, it's hands-on. They don't need to, put the satellite up in the sky, but they need to select data that is relevant to them to work with. And I'm wondering if it's possible, or if there is such a source that I haven't found yet, where all sorts of local data is available for students to use and manipulate to get data literacy that is place-based and is relevant to them. I know all of the, Landsat and all of these data are there, but they're not necessarily in a format that students can use, undergrad students or high school students. You need to be an expert to translate, the chlorophyll data, or the irradiance, to change it to chlorophyll and so on. And I think it would be really important as a tool for instructors to be able to have the kind of translated data that they could use and look at.
So I'll answer Aries and then I'll let you follow on. I don't know of exactly what you're looking for. I would say that there's a couple of things that come to mind. So one, develop, which I told you is these 10-week projects that are student projects that are overseen by a science advisor. They put out these galleries of all of their projects. So there's a lot of use cases, what we call use cases, that you can kind of see examples of the kinds of things, and then they talk about how they did it. So that's one resource that's out there. Another thing that our data folks have been doing, they have something called data pathfinders, that they're trying to make it simpler, that if you're going to do an agricultural project, for example, that you know that you go to the agricultural pathfinder and it helps you find data related to that theme. We've also, within a project called Unbound, it's a way of listening to user groups that perhaps know nothing about our NASA data and trying to see how they can interact with our data now and where they have the stumbling blocks, and how they, therefore our data guys will make it better. And so they just had one on environmental justice. And as that's an increasing focus, not only in my own portfolio, but across our science division. And some of the lessons learned, I think, from that was that, these were communities that had environmental issues and were underserved, but didn't have necessarily the experience or even thought about, interacting with NASA data, right? It's complex sometimes. And so there was this need for this boundary organization. I heard that one of the talks here, where, sometimes you need folks who know how to do it. So Aries, I don't know of anything that's place-based student data sets. Do you?
Yeah, you mentioned a globe earlier, but that's not quite it. That's more of a citizen science project. I know that we have a Space Act agreement with Google Earth, and I know that there's plans and discussions on doing maybe closer to what she's talking about, which is, I want to know what's happening in my town. But I think that's exactly why Nancy's program, it thrives and why Applied Sciences exists, is because we hear these things and then we go back and we're like, we should do this. We should come up with this type of interface that people could use. And finding out from people like Adina, like, so tell us, if you could ride the unicorn on the rainbow and you'd want to, how would you like this to look? And then we can see, all right, we actually do have data that fits this. Here's how we create it into a different tool to do that. But yeah, that's what I don't think we've got anything specific like that. As Nancy said, a lot of things are broken up by topic and fairly well, but not necessarily just by place. But I'd like to follow up with you and see what we've got. I do think that Google Earth is doing an amazing amount of work in adding to what they've got there. Now, I don't know if it's all NASA data, and how available it is, but yeah, let's see what we can talk about.
An example that comes to mind, for example, sea level rise. So there's this interactive tool that you can focus exactly on your neighborhood and go back in time and forward and see how it changes. And I think that's a great educational tool. You can do something like that where you have the data available, for example, for soil moisture, or that I know NASA has stuff like that, but it's not readily available in a format that students can actually plot the soil moisture in their agriculture field seasonally, for example.
Right. Yeah, I mean, well, if anyone else is interested too, there is a program called OpenET, though that's still very specific, I think, to water resource managers and agriculture people. But it does do water plotting, and is designed to do it in a way where you can do it at the field level. That's another possible resource, but that still falls into, we tend to do things by topic and not so much by location, but we have topics that cover lots of locations. So I think we can investigate it further.
I need to dig more into these.
Yeah, and that's where also having a guide, that's big part of what I do, what Nancy's program does, is trying to guide people through what NASA data we have, what we've got where, and putting it into the hands of people who can use it, and training people up on how to use it. The RSET trainings are amazing, and they're always been online, and you can just walk through how to look up data, and that's just one of the many training programs that we have.
Great, thanks. Any last comments or questions? If not, looks like most people have moved on. The meeting is over, so let's thank all of our speakers again.